I think that's a completely different talk to the ones before, because we don't work on the ontology development. We want to use ontologies, and I've seen a lot of the speakers before are coming from the life science area. So that means that life science has a major impact in the chemical developments, which is good for us because we are coming from the NFDI4Health is in the life sciences. We are the national research data infrastructure for personal health data, and we are focusing on structured health data coming from epidemiological and public health studies and clinical studies and health registries, and would like to make these data fair. So that means, and the first few, we would like to focus only on structured documents and very structured data, but if we dive into it, going to omics data, then we have the whole world of chemistry and what you are focusing on. But nevertheless, if we are looking for terminologies, ontologies, we would like to use that to semantically enrich data and make it interoperable. So similar as Oliver already told you, that's the focus on the NFDI. And we do that in using a semantic lookup service, the same one as NFDI4Chem based on OLS and OXO, and would like to enhance the semantic interoperability of all the data collections. And in addition, we also use the terminology service to within a metadata annotation service. Oh, that I don't want now. So that means also we have a separate set from terminologies compared to OLS and OXO based on two views. On the one hand side, we only want to use a subset to reduce complexity. On the other hand, we need to add the terminologies which are currently not in the public services. And these services are also publicly available. And what we use very much is the search and the visualization widgets, because we would like to use it in other services. And as I have said before, we transform also mainly medical terminologies like such as LOINC or ICD-10 in OLS compatible formats in OWL and include them. And one major focus is that we use then these widgets in different services, for example, in a semantic literature search engine, or as I said before, in the metadata annotation service, to make these questionnaires and variable catalogs, which are coming from our users, to make that compatible and interoperable because we annotate that to the external terminology. So the main focus looking on studies, study documents are medical terminologies, and I have marked here in blue, which also contain partly chemical entities. We use the medical subject heading, the food ontology. LOINC also contains in the laboratory area chemical entities. They all do not link to chemical ontologies. On the other hand side, we use the ATC, which is well known in the chemical area and well linked. And for Germany, we also will include the German medication list, which is focused on the German medication. If we are looking for biomedical research, I think all these other ontologies has already provided that. We need a lot more ontologies, and there we also use the CAPI as one of our ontologies. The basic idea how we would like to use it, and have done that in another project, and is that we really want to use the terminology as a link and as a service on the one hand side to annotate data, but on the other hand side really also for data analysis. That's the focus, and that means we need also linking of different ontologies. And that's my last slide, my questions, what I have on the ontology development. We need different domains for data annotation, so that means I would like to rely on the chemical area that they provide the ontologies. The problem we have with annotation is that we have a high overlap of entities in different ontologies, and that makes it very hard for a simple user to get an annotation right. So that's what we face currently, not for chemistry, but also for our ontologies, which is a major problem. And we have also, for some of the ontologies, very different properties. For example, in FoodX and SNOMED, they use post-coordination of terms. That means most of the terminology service we currently use don't support that. We need really the specified tools there. And that means at the end, we need also a combination of service for this application. And with that, I would like to end.
Yeah, thank you very much, Philip and Oliver, for the kind introduction and invitation for giving the talk. I hope you see my presentation mode.
Yes, looks fine.
Okay, and yeah, I'm Norbert Kockmann from TU Dortmund University. From training, I'm a mechanical engineer, and I'm representing the process engineering part in the NFDI4Cat. And I will start with our approach. We first ask us for what can we use the ontologies, then going to a collection of ontologies representing the field of catalysis and process technology, and then the selection of ontologies we are currently working with. So first the definition or the question what we can use. And for us, the ontologies are a network of information with logical relations and interconnected metadata. And we started already with metadata, but without any underlying ontologies. That was a difficulty, particularly in our project. So we have data standards from projects, from institutes. They were readable for humans, but not really for machines. So the FAIR principles were not really covered with this. So we aimed to get the ontology connected to these metadata. And for this, we looked closer, what is an ontology? And there's nothing new for this community. And we set up a kind of basic ontology here, what a kind of reaction with the properties here of a catalyst as a substance, and a typical catalyst is an iron catalyst. So with this, we have a unified data format through ontologies and through standardized metadata schemes, which we can use then in projects, in research projects, in electronic lab notebooks, which is also a large task in our consortium. We started with the data value scheme or value chain here from the molecular part, catalysis data, transport phenomena, kinetics, up to process design, so real chemical process, a syngas plant or other catalytic plant, which is the connection to NFDI for the engineers. And on the lower part, we have the connection to the chemist, to the material science. We divided these catalysis data in 4 topics: the synthesis of catalyst, the working with catalyst, the operando data, the performance data, and the characterization, so the analytics, sometimes very particular for the catalysis. And we covered this area with existing ontologies, and you can have a look on our homepage where we set up this ontology collection. Some are already mentioned here today, or were mentioned today. Others are new, and I will go at the end of my talk closer to the OntoCape and the OntoKin ontology. What are the characteristics and also the limitations? So we try to work with, or we looked closer to some. We worked, for example, here with the biocatalysis ontologies or markup languages. Have also with Mark Durr a common publication in this area. So this is more a collection of what is available on the market. But although there are many ontologies, they are not sufficient to describe this catalysis research in total. So we need to combine ontologies or to map ontologies. And there we started with the top level ontology. We searched for a good one for us. And here are the characteristics. I don't want to go into much detail, but we found out that the BFO which was also mentioned earlier, was suitable for us as a top level ontology to get there the concepts into our approach. Then we have a closer look to existing ontologies, starting with OntoCape. That has a quite good modular setup, but no easy handling of the sub-ontologies. The combination was quite difficult. It has no alignment with an established top-level ontology like the BFO, and the reasoning, so the automatic improvement of the ontology was giving some errors, and it was difficult to fix. So there are some inconsistencies in the OntoCape. That's the reason why we a little bit looked for other, or we then look for other ones. The OntoKin is a very small ontology with only 59 classes. No top level ontology concept is behind that. Some classes are missing annotations, so it is not really operable for our purposes. So here's the selection of the ontologies we most work with it. The AFO, Allotrope Foundation Ontology, because of its standard vocabulary and semantic model for the laboratory analytical processes. You probably remember one of the puzzle pieces on the lower left side. Then the Chevy or Kevi is one of our working ontologies. It was also mentioned today. Then the CHMO, it's quite interesting because the methods describe the chemical experiments as well as the instruments. And we use also the NCIT from the National Cancer Institute Thesaurus. It's not based on the BFO as our top level ontology, but the classes are quite usable for us and relevant to chemistry. And the UPAC Gold Book, for us, it's not an ontology in that way, but it has a good structure and nice definitions for the classes. That's the overview. Tomorrow there will be another talk from Alexander Baer on working with this ontology, or a short presentation directly at the beginning at 2:30, and there will be more details then on our approach. With this, I'm at the end, and I want to thank you for your attention and the invitation.